All right, guys, we're going to take a look at evaluating functions with arithmetic sequences. I just want to show you the connection on how similar really they're the same. So you're going to copy everything after the equal sign into Desmos like you did when you evaluated an equation. So you're going to Google Desmos, graphing, and then the state that you're in so you can get the state test version so that you're always practicing off the calculator that you're going to be given. All right, so I'm in Georgia, so make sure that it says the state that you're in right here. It says copy everything after the equal sign into Desmos. So I'm going to do example 1 all the way this way, and you're going to do example 2 all the way this way. So I'll do example 1. I'm going to copy everything after the equal sign, so 2x plus 5. Replace the letter with the appropriate number. So remember, we're evaluating a function, right? So you're going to replace the x, put it in parentheses with the number that you need. So I want to evaluate when x, the input, see x is equal to 1. So I'm going to put in 1. That's equal to 7. So f of 1 is equal to 7. Now I want to evaluate for 2. So I'm going to put 2 where x is supposed to be. That's equal to 9. Then I'm going to put it for 3. That's equal to 11. Then I'm going to put it for 4. That's equal to 13. So your sequence, right, the very first number it starts with is 7, then 9, then 11, then 13. Okay. All right, I'm going to do the same thing for explicit. So this is in function notation where you see f of x is equal to some output. That's function notation. Now I'm going to look at what does it look like in explicit. And if you look on the previous page, you'll see the explicit formula. All right, so now I'm going to evaluate. Again, you're still copying everything after the equal sign. So delete that, copy everything after the equal sign. N minus 1, close parentheses, plus 7. Double check that it looks exactly like that. It's giving me an error. I don't really care if it's y equals, it should still work. All right, then replace the letter. So this time the letter, instead of it being x, is n, because you see all my function is, or in my explicit sequence is in n. So I'm going to replace n in parentheses. So wherever my letter is, just always put parentheses there so that you know that whatever goes inside there is what you're looking for. So when n is 1, it's 7. All right, when n is 2, so I'm going to replace here. This would be the n right here with 2. So it's going to be 9. When n is 3, so replace this with 3. It's going to be 11. And you can already see the pattern, right? Before I even put this in, it's going to be 13. Because these are just two different ways of writing the exact same thing. So what's the sequence on this one? The first one is 7, then 9, then 11, then 13. So once again, different methods of writing the same thing. So we're looking at a function where you have f of x, in explicit form where you have a sub n is equal to something, right? And now we're going to look at recursive. So recursive, remember, you have to know the previous term in order to do the next one. All right, so let's go ahead and evaluate this. Again, we're going to type in everything after the equal sign. So we have, okay, we're going to put parentheses in this one because it's not something I want to spend time typing in because we're just going to delete it. So everything else, we're going to type in. Now, if you remember from the previous video, go look at what the definition is of a sub n minus 1. All right, so this again means the previous term. So we're going to rewrite it in here as well so that you have it. So I'm going to put it right here, and we're going to write this is the previous term. All this, this whole thing is the previous term. All right, so go ahead and write that down. So you're going to take the previous term, and then you're going to say plus 2 to it. So evaluate a sub 1. Well, they tell you a sub 1 is equal to 7. So you're going to put 7. All right, evaluate a sub 2. Well, a sub 2 will be the previous term plus 2. So what's the previous term? 7. So it'll be 7. Where's my mouse? Plus 2, which is 9. All right. A sub 3, the previous term plus 2. What's the previous term? 9 plus 2, which is going to be 11, that you can put it in the calculator. All right, repeating it again. We're looking for a sub 4. It's going to be the previous term. So the one right before that, which is 11, plus 2. which is equal to 13. And as you can see, regardless of the way it is written, all three things are the same. So this sequence is also 7, 9, 11, and 13. So I just wanted to point out that they're all literally the same thing. They're just different representations, different ways to write it. All right, so now you're going to go ahead and do these. All right, so you're going to pause the video, complete that. All right, then I'm going to come here and we're going to finish this off. Okay, so let's say they give you the sequence. So before they gave you the function and you wrote the sequence. Now they're giving you the sequence and they want you to write the function. Same thing here. They gave you the explicit notation and they wanted you to write the sequence, but now they want you to go from the sequence to the notation, and it's fine. You can do that as well, relatively easy. So let's start off with the sequence here. All right, I've shown you how to do this before. All right, so this is n equals 1, n equals 2, n equals 3, n equals 4. And you can do it by hand relatively fast, but I'm going to go ahead and do it in the calculator since, that's what we're focusing on. So we're going to put in a table. All right, when n is equal to 1, y is equal to 15, or the sequence is equal to 15. When n is equal to 2, the sequence is equal to 11. When n is equal to 3, the sequence is equal to 7. When n is equal to 4, the sequence is equal to 3. So we're inputting our table in. Right? In order to get an equation, you have to go y sub 1, so y1, squiggly line, which is shift, then right up underneath your escape button, or you can click this, A, B, C, and then it's right here on the bottom. And then mx sub 1 plus b. We've done this before. If I'm going too fast, please pause and rewind and watch me type it in, or watch the video that says write from a table. All right, so now I've got it. I write the equation, which is y equals mx plus b. It's what I want to see. And I'm going to replace m with what m is, which is -4. And I'm going to replace plus b with what b is, which is plus 19. So this is my equation. And as long as everything lines up, so the black dots to the blue line to the green line, I know that I'm correct. So my equation is equal to y equals -4x plus 19. All right, now we're going to do the next one. So we're going to go from this sequence and we're going to show that we're going to get this exact same equation because the sequence is the same. So let's do this from our formula. So we have a formula on the previous page on explicit, which says a sub n is equal to a sub 1 plus n minus 1 all multiplied by d. So now we're going to put in our what everything is. So this is a sub n is equal to my first term. What is my first term? 15 plus n, because I don't know which term they want, so I'm just going to write this in general, n minus 1 times d. So what is d? My common difference. So what am I doing when I go from here to here, here to here, here to here? Or if you just look on the previous page, your common difference is the second term, which is 11, minus the first term, which is 15. So my common difference is -4. All right, previously I had let you leave it just like this, but I'm not going to let you leave it now because I want to show you that it's exactly the same as this. So we're going to simplify this. So we're going to write a sub n is equal to, and what we're going to do is we're going to distribute this -4 into our parentheses. So this is going to be 15 plus -4 times n, which is -4n, right? -4 minus 4, let me just leave this in parentheses. -4 times -1, which is +4. All right, so now we're just going to rewrite this. So this is equal to, when you distribute a positive, it's not going to change anything. So it's going to be 15. The positive times a negative is a negative. Positive times a positive is also a positive, so it stays to that. Then let's go ahead and combine like numbers. So which ones are the like terms? 15 and 4. Okay, and I'm also just going to put this -4n first, and you'll see why in a second. So this is -4n, and then 15 plus 4 is what? 19. What do you notice about this equation and this equation? They're exactly the same, they just have different variables, because again, function notation, explicit notation, recursive notation, 3 different ways of writing the exact same thing. All right, so looking at recursive, all right, here's your sequence. Write it as a recursive function. A sub 1 is 15. A sub n is equal to the previous term plus d. And what's d? What's the common difference? It's the same as this, which is -4. So I'm just going to simplify that. Positive times a negative is a negative. So this is a sub n minus 1 minus 4. And without us being given, this is the general form, so it's not going to look like this because it's written a little bit different. However, any number that you pick will end up being exactly the same.